Now another main important concept here is shapes of wavefront. This concept is very important for the competitive exam. We know there are three types of wavefronts. Now, important concept here is the shapes of wavefronts of reflected waves. Shapes of wavefront of reflected waves. You know reflection. Shapes of wavefront of reflected wave. You know the phenomenon of reflection. For plane wavefront, we consider this concept for the plane wavefront. If plane wavefront is reflected from plane mirror, reflected from plane mirror, for plane wavefront, if it is reflected from the plane mirror, then reflected wavefront is also plane. Reflected wavefront is also plane wavefront. There is no change in its shape. See, shapes of the wavefront of reflected waves. If plane wavefront is reflected from the plane mirror, the reflected wavefront is also a plane wavefront. But if plane wavefront is reflected from curved mirror, that is convex mirror or concave mirror. Here the reflected wavefront is spherical. Important point. The reflected wavefront is here not plane, but it is spherical. Reflected wavefront from the curved mirror, the reflected wavefront is spherical. You know the spherical wavefront. Similarly, we see shapes of wavefront of refracted wave or refraction from the plane surface. Shapes of wavefront of refracted waves. You know the phenomenon of refraction. Change in the direction of light when it passes from one transparent medium to other, we call it as a refraction. Now, what is the shapes of the refracted waves or shapes of wavefront of refracted waves? Refracted waves. Suppose light is refracted by using the glass slab. If plane wavefront, we consider here incident wavefront is a plane wavefront. For plane wavefront, we know the rays of light are parallel. If plane wavefront is refracted from plane surface, plane wavefront is refracted from plane surface, then the refracted wavefront is also plane. Refracted wavefront is also plane wavefront. Plane wavefront is refracted from the plane surface. Refracted wavefront is also a plane. If plane wavefront is refracted from curved surface, like a convex lens, refracted from curved surface, then refracted wavefront is spherical wavefront. Refracted wavefront is spherical. So here main thing is, on reflection or refraction of the plane wavefront from the plane surface, the reflected or refracted wavefront is a plane, but from the curved surface the reflected or refracted wavefront is spherical. These points are very important. The shapes of the wavefront after a reflection or after a refraction. The next important concept here is, these concepts are very important. Write down these points. Next important concept is Huygens principle of secondary waves. Very important. Huygens principle of secondary waves. Huygens principle of secondary waves. By using this principle, we can find geometrically position of wavefront. We can find the position of wavefront at later instant. Position of wavefront at shape and position of wavefront, shape and position. What is the use of this Huygens principle of secondary waves? By using this principle, we can find shape and position of wavefront at later instant, that is time. At later instant, that is at later time, if its shape and position at earlier instant is known. If its shape and position at earlier instant is known. So what is this principle? By using this, we can find the shape and position of wavefront at the later instant, if its shape and position at the earlier instant is known. According to this principle, every point on wavefront acts as a secondary source of light. Every point of wavefront acts as secondary source of light. Secondary source. You know primary source and secondary source. And it emits the secondary waves in all directions. It emits the secondary light waves in all directions. The surface touching these secondary wavelets, it emits secondary waves in all directions. Secondary waves. These waves are called as wavelets in all directions. See the principle. Every point on the wavefront acts as a secondary source of light and it emits the secondary waves. We call it as wavelets in all directions. The surface touching these secondary wavelets, the surface touching these secondary wavelets tangentially, surface touching secondary wavelets tangentially, surface touching secondary wavelets tangentially in forward direction at any instant, in forward direction. This word is important. In forward direction at any instant gives new wavefront at that instant. Gives new wavefront at that instant. It gives the position and shape of new wavefront at that instant. What is the principle? It gives shape and position of wavefront at later instant, that is at later time. If its shape and position at earlier instant is known or earlier time is known, every point on the wavefront acts as a secondary source of light. It emits the secondary waves or wavelets in all directions. And second important point here is the surface touching the secondary wavelets tangentially in forward direction at any instant gives new wavefront. Now we know construction of spherical wavefront and construction of plane wavefront. You know these concepts. In spherical wavefront, we consider a point source of light, yes. If c is velocity of light, the light covers a distance c into t in time t, and light travels in all directions, so it covers the same distance in same time, and this gives the spherical wavefront. See here, this is the spherical wavefront. Every point on this wavefront acts as a secondary source and it emits the secondary waves. Every point on this wavefront acts as a secondary source and it emits the secondary waves. So here we draw the spherical wavelets like this by taking these points as a center. Suppose this is point A, this is point B. We draw these circles, semicircles. This is point C. This ABC acts as a secondary source and we draw the spherical wavefronts like this. As light does not travel in backward direction, this wave traveling in forward direction is effective, and this tangential surface is the new wavefront. Suppose this is our spherical wavefront AB. Suppose this much part. This is AB. Yes. Suppose this AB is a spherical wavefront. We consider point, suppose PQR on this spherical wavefront. This PQR acts as a secondary source of light. PQR acts as a secondary source of light. We take P as center, Q as center and R as center, and after time t it covers a distance c into t. And envelope of all this spherical wavefront is A dash B dash. AB is original spherical wavefront. A dash B dash is new spherical wavefront after time t. This is new spherical wavefront after time t. After the time t. So this is construction of spherical wavefront according to Huygens principle of secondary waves. You know this theory. Also you know the construction of plane wavefront similarly. Suppose plane wavefront is moving from left to right. Suppose this AB is a plane wavefront. it is moving from the left to right. We consider points on it. Suppose these are the points PQR. According to principle, these points acts as a secondary source of light. After time t, it covers a distance ct. This distance is c into t. And envelope of all these surfaces or line touching all these surfaces is suppose a dash b dash, and this a dash b dash is our new plane wavefront. AB is the original plane wavefront, A dash B dash is new plane wavefront. These points are very important. This theory part is very important. If you know all these basic concepts, you can easily write or solve the MCQs based on this theory part.